Dispelling the top 10 myths about entertainment motors. Do you think you know everything about motors used in the entertainment industry? Join us today, and we're glad you're here as we confirm or bust the myths with our training expert, Dave Carmack. Dave is a 40-year veteran of CM. He served many roles during his tenure. His experience ranges from 20 years of actual manufacturing and production of the Lodestar product and the mechanical and electrical construction of CM products. He also worked on troubleshooting and repair and engineering research and development in his roles as lab technician and product engineer before becoming our entertainment trainer. Dave has taught classes on 6 of the 7 continents. My name is Gisela Clark. I'm the social media and e-learning specialist at Columbus McKinnon and will be your host for today's webinar. As I said, we are recording the session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end to answer them. So thank you again for your attention, and now I'll turn the meeting over to Dave so that we can begin.
Okay, thanks, Gisela, and hello to everybody that's up there. As Gisela said, my name's Dave Carmack, and I am our entertainment product trainer. I'm located in Damascus, Virginia. If you guys don't know where Damascus, Virginia is, or you never heard of Damascus, Virginia, Google it, because I think you will be surprised at how small of a town we are. We have a total population, and get this, 815 people. So we are a really small town, but that's kind of where I'm based out of. I work out of the factory that manufactures the CM branded products. But when Gisela come to me and asked me to do this, I thought it would be fun if we could just kind of discuss the top 10 myths or questions or comments of things that I get during my training classes. So what I try to do is I try to kind of pick out the top 10, maybe not in this order of the top 10, but these are the most frequent asked questions. So, but first of all, before we get started, let me clear a couple things up. If you actually look at this slide here, you'll see it says starring Dave and David. Well, no, there's not actually 2 of me here, and I don't know all that's out there, but a lot of people already knows the story behind the Dave and David. It's just a way that I try to make my classes fun. When I tell people I teach a large class, for a long time, if I don't keep a way of making it fun, then, it's going to get boring and I'm going to lose you. So I teach in 2 personalities. I teach in Dave and David. Dave is the guy that you can trust. He's the straightforward guy. He's the one that teaches you the rights and the wrongs. Now, David is like the dark side of Dave. He's the one that kind of comes along and pushes the limits, bends the rules, and not exactly leads you down the wrong path, because Dave is there to actually bring you back. But it's just a way that that I teach, that we kind of have fun with it. Also, a lot of people really don't like David, and I've been told before to leave David at the hotel. And I will still get emails today addressed to both of us. But it's just a way that I have fun with my classes, and the class kind of likes it as well. And so hopefully, David being the dark side of Dave, we can keep him quiet today. So it's kind of an inside story. Another thing is I want us to make sure that we're all on the same page. We got a little bit of terminology difference. I'm sure that out there we've got entertainment people and we've got industrial people. Just a couple of terminologies to make sure that we're all on the same page. Whenever you hear me talk about a motor or a chain hoist, that's the same thing. The entertainment guys actually calls a hoist a motor. So as we're talking about that, sometimes I will call it a motor, and sometimes I will call it a hoist. If I'm referring to just the stator or the motor that's on the inside, I will call that a stator. Another thing that we talk a little bit different about, we call our control station a pickle. I told Gisela this morning, she wasn't aware of this, but if you guys have an idea of why we call a pickle, if you will type it in, the first person who gets it correct, we will get, we'll send you out a shirt. So A pickle is a control station, and then I will refer to tails as the control cords or the cords that are coming out of the motor. So with that
Okay.
said, pardon?
Okay, we'll go ahead. No, please, go ahead. Yes.
Okay. What we're going to do now is Geisha, we're going to start with the number 10 and work our way back to the to number 1. So what is the myth number 10?
Okay, well, first of all, I just want to answer a couple quick questions. We will be seeing who has the right answer on that, and that winner will get something at the end. But we're going to do this like an interview process. So not interview, just kind of a Q&A. So I'm going to read the myths and then go down, and then Dave will address them. And Dave, when you come back, I want to make sure that we can hear you a little clearer. There's just a comment that maybe you could turn the volume up a little bit or get a little closer to your laptop so we can hear you a little clearer. Okay, so myth number 10, a motor can hold a load indefinitely. Question from the field is this: many of our motors are used to raise loads. Once the load is in its permanent position, we disconnect the power, and the power supports the load indefinitely. Is this a good idea?
I think this one, the name is kind of in the, or the answer to is kind of in the name itself. You know, it's called a hoist. A hoist is designed to help us lift and lower heavy loads that normally, you know, we can't. It's really not designed and intended to support loads for any length of time. You know, whenever we operate a motor, we really don't think about what's actually going on between the two hoods. You know, when we hit the pickle and we energize a motor, the first thing we energize is the stator. The stator is fairly weak in our motors. They don't have to be strong because they see very little of the load. Most of the strength that it takes to lift these heavy loads is made in the gearbox. So between the weaker stator and a heavy load is the gears. Now, if you get inside the gearbox, you'll see that our gears has a lot of teeth on them. But if you look deeper, there's only 1 or 2 or 3 of them that's actually working at any, you know, a certain time. So now let's think about that. You just think of all the forces and stresses and stuff that's on those gear teeth. It's a good idea that once we get a load that's up in position that it needs to be, is for us to use a secondary support, tie it off with something, and then take most, if not all of the weight off the motors and let the motor become the secondary support. Because if we leave the load on it.
Excuse me, really quick, Dave, are you advancing the slides?
Well, I'm not ready. Oh, no, I'm not. I'm sorry. My bad.
I apologize. I just want to make sure that we're not having a technical issue. I'm sorry.
No,
Go ahead.
Well, anybody who's ever sat through my class knows that I'm very unprofessional to start with. But and I apologize for that. But anytime that we leave a motor suspended, you know, and it's supporting the load, we've got a lot of forces that's in between those couple of gear teeth. You know, and over a long period of time, we could start putting flat spots on our gears. And then it's going to just make the motor, whenever we do start using it again, to be a little bit more noisier. This, as I was preparing for this, it made me think of a story that I once heard from a legend that's in our market that says that accidents don't happen. We create them. And we create them by overlooking little tiny things or using products outside of their normal design. And he referred to a chair. You know, very rarely do we hear of a person getting injured sitting in a chair. We get injured when we use that chair that's intended to be sitting in as a step ladder. That's kind of where it all comes about. Will that chair work as a step ladder? Well, absolutely. But it's not intended to do that. Will our motor support a load forever? Absolutely. But it's not intended for that. Whenever you use a product outside of what it's intended for, you do induce that risk or a possibility of something going wrong. So with that, we'll move on.
Okay. So myth number 9, bolts and screws do not need to be torqued to a specific value. Question from the field. Product manuals often claim that fasteners need to be torqued to specific extremely high values. It's difficult to do this. If we tighten them as tight as we can, isn't that good enough? Hold on, Dave. What's the answer there, Dave? You can advance the slide.
Well, we're going to have to bust this one because tight is not good enough. When we torque something, I always ask in my class, why do we torque? And somebody always says, well, make sure we got it tight or we got it over tight. But we go beyond that. You know, what we're really asking you to do is we're asking you to basically put enough force on it that will deform the threads. If you look at the slide that's on the screen now, you'll see that the arrows, the red arrows, is actually mating with the threads on the other part. But the gray one is kind of out there in midair, really not serving any purpose. And the reason this way is because we can't build two things exactly the same. To drive that home is, if you look at any kind of engineering drawing that's out there, I dare say you will never find one that doesn't have plus and minuses, because that is our way out, because we can't build two things exactly the same. We could have our fasteners designed to the tightest tolerances known to mankind, but still they're not going to be the same. So we're going to have areas that's really not performing. So when we are giving you torque values, even though some of them are tremendous, we really need that force to deform the threads. That's going to deform the threads to where that gray one actually does come up and contacts the threads. If all we had was a couple of thread area that was making contacts, there's a greater possibility of that bolt breaking than it would be if we put the correct torque values on it that deform the threads to where all the threads is actually sharing the load in just the two or three. So in this case, this myth is busted. Tight is not good enough. Okay, number 8.
Okay, moving on to number 8. It is okay to use non-CM parts to repair or use with CM motors. So the question from the field is, CM states that all the components inside the motors must be supplied by CM. I can find parts at the local hardware store for a lower price. Do I really need to purchase all replacement parts from CM?
Well, again, I'm going to have to bust this one again. And I hear this a lot, and I've actually heard it referred to as the CM tax, because, we have to get the stuff from you guys. Yes, you can go to the hardware store, and you can get nuts and bolts, and in some cases chain. And in some cases, you can get them just as the same grade as what we use inside of inner products. But hoist designers, they don't randomly take parts and put together. We design for the motor to be the most efficient and have the maximum performance that's out there. So what we do is, even some of our grade 8 bolts and things like that, let's just take a bolt for an example, the hex bolt that's on top. We may round off the sharp corners off the points of the hex, so it doesn't really dig into to the mating part. And that makes it safer. So in reality, the performance of one part actually depends on the performance of another part. And in my classes, I talk about the load chain, because the load chain is really the most common thing in a chain motor. But, all chain is not really created equal. I joke in my classes and say that when CM needs a piece of chain, that we don't own a chain mine. And we don't go down in the mines and in that 5/16 vein, we dig out a piece of chain. But somebody does dig out minerals. And then when they dig out the minerals, and then it becomes a process like baking a cake. What they do is they add a pinch of this or a dash of that, they stir it all up, and then they form it into what we need, whether it be a I-beam or a flat piece of steel, or in this case, it's actually wire. You can find chain out there. You don't have to look very hard to find a chain that you can lay side by side with our chain, and it will equal the wire diameter, in this case 5/16, and will equal our pitch. And laying side by side, you couldn't tell the differences in them, which means it will fit inside of the motor. And I always ask this, does it work? Will it work? And I can't say it won't, but I will say probably that it won't, because do they have our special recipe for our chain? We have our own special recipe. And then, again, back on thinking that we don't really think about what goes on in between the two hooks. There's a lot of vibrations and movements that's going on inside the motor. Our chain has to be heat treated in a specific way in order to make it, make it safe. Does it have those properties? If I put a piece of chain in our lodestar, because of the vibration, if the chain is too hard, it's been heat treated too hard, then it can't handle the vibration. So it's a possibility that that chain would break. Then on the other hand, if the chain is too soft, because of the vibration, the chain will actually stretch. Well, when it stretches, so does the pitch. The pitch is just a measurement over the length of the chain there. That changes. Well, the pitch of the chain has to equal the pitch of the lift wheel that's on the inside of the motor. So before you know it, we're chewing up the chain guides and we're actually doing damage to our lift wheel. So the parts do have to be supplied by Columbus McKinnon. It's not that we want to make the sale. It's that we design for our motors to have the most of the highest performance. And by doing that, one component performance really depends on the performance of another. Okay, moving on.
Okay, myth number 7. 5-to-1 design factor rating on a motor lasts forever. Question from the field. ANSI E1.62 hoist maintenance and design standards for entertainment tell us that motors must be designed with a 5-to-1 safety factor. Does this design factor rating last forever, or does it decrease over time?
Well, this is one that I think is really mostly misunderstood. I always ask in my class, how long does a design factor last for? And just about everybody says, with a little bit of question in their voice, well, it lasts forever. Well, and in explaining this, I always talk about our motors as being no different than people are. When a motor, when it really works hard, just like we do, we get tired and we have to rest and we get hot. When we're not happy, we complain and we tell people we're not happy. Our motors do the same thing. So let's kind of look at it like this. I can remember the day that when I was a young guy, I worked 8 to 10 hours out on the shop floor, and then I would come home and work on the farm for another 8 hours. And when I walked up to a 200-pound bale of hay, it wasn't nothing for that young guy to pick up and throw around. But I'll be the first to tell you now, since I am older, I can't do the work that I used to be able to do, and I'm not as strong as I used to be able to do. So a hoist is really no different. The older that the hoist is, of course, and the more you use it, the strength of it is going to actually go away. A lot of people will say at this point, well, that's not a good thing. Well, our hoist engineers, they take that for granted, because I guarantee you, every one of you guys is sitting out there and has heard this comment. Well, the CM motors is always too big and too heavy. Well, when I hear that, I always want to say, well, thank you, because that is a compliment. Because our motors, they are bigger, they are heavier, because we take that into consideration, and we have a higher than a 5-to-1 design factor from the beginning. So we want our motors to last a long time, so that's why we're actually bigger and heavier.
Hey, Dave, can you change to the next slide, please?
Yes, I am sorry again. Okay. Okay, well, moving on to myth number 6.
Okay. All right, myth number 6. A brake gap that's too large can prevent the brakes from operating correctly. Question from the field. I understand the need to maintain a proper brake gap. A gap that's too small will cause the motor to drive through the brake. But how can a brake gap that's too big cause resistance with the motor? Okay, Dave?
Well, this is a good question here. Again, our motors are, and I'd say that they're just like me, they're stupid. They really don't know the difference in a massive heavy load or an overload as the brake is just out of adjustment. And just like the question here said, that the brake gap is too small, it's just like driving your car on the interstate with your foot on the brake. It just makes it work harder. But the brakes on the inside of a motor really just relies on a magnetic field to actually operate. And if the gap is too big, we may not have enough strength in the magnet to pull the parts together that's going to release the grip on the brake disc. So again,
Dave, I'm sorry, can you advance the slide?
I'm sorry. I'm not doing very good.
No, that's okay. I apologize to interrupt, but now continue, please.
Okay, and again, when the brake gap is actually too big, there may not be enough strength in the magnetics to actually overcome the brake gap. So again, we're just kind of driving through the brake. So it really is important that we do keep our brake gaps together. Just like I said in the earlier slide, most of the strength is made to lift the load inside of the gearbox, and the stators is fairly weak, so it doesn't take a lot of restrictions on the rotor to actually make the motor work a lot harder. And this being halfway through, I promise I will get better at changing the slides.
Okay. All right. Dave is so used to presenting live. That's his forte, so this is kind of new. All right. Let me do myth number 5. Reverse phasing a hoist is safe. The question is, we all know that changing the phasing on our distribution box will result in the motor running in the opposite direction than marked on the pickle or control station. But I need this extra travel, and I don't want to take time to adjust the limits. Why is this a problem? And let me mute. Okay, go ahead, Dave.
Okay, I think this comment or question comes out of because most of our controllers or distro boxes will have a phase reversing switch on it. And the way the foundation of this is there is no governing standard that says that a venue or a building be phased with the correct power. So L1, L2, and L3 will not constantly be the same thing coming in. And what I mean by that is if I hang my show in venue A and I plug it up this specific way, and it operates, and operates correctly, ups up and downs down, I could take it down, do a load out, and move it over to venue B, hook it up exactly the same way, and because the building itself is phased incorrect, now when I hit the up button, it's going to actually go down. So that's why the controllers actually have the phase reversing switch on it, and that is just to make it a little bit easier on us to make that correction without having to unwire the connectors and all that stuff. Just all we got to do is flip the switch. It's not intended to give us that extra trouble, because really what we're doing is we're overriding the limits. The limits is the only protection that we've got against running the chainer out of the motor or running a steel hook block up into the bottom of the aluminum housing. Rock, paper, scissors is going to tell us when a steel hook block hits the bottom of the aluminum housing, then the aluminum's going to lose. So first of all, that's what we're doing is we're overriding the limits. And second of all is because you got to think about this. It is a simple design. It's just a micro switch, and then when it's engaged, we're actually our travel nuts on the inside of it is actually already compressed the switch to the point it's opened up. So it really can't go a lot farther. So if we need a lot more lift, I know it's awful easy to walk over and flip that switch, but if we go any distance, we're going to actually break the switch off. The limit switch brackets is really our #1 seller. We sell more of those than we do anything, and it's because people don't understand what they're doing when they're phase reversing. Just because CM says we don't like the phase reverse doesn't mean that you're going to have to stop. What it says is understand what you're doing is by phase reversing, you are overriding some of the protections that we put in there for you. Now myth number 4.
Okay. Whoops. Myth number 4, motors set to run at the same lifting speed will lift a load at the same rate. So if I have 2 or more motors lifting a load and these motors are running at different speeds, I must have some kind of problem going inside the motor, right? Go ahead and share the answer, Dave.
Well, I think this situation is kind of grew out of proportion here lately because 30 years ago when we built stages, it was probably consisted of 2 step ladders and an extension ladder going across the 2 step ladders. But now we really built some souped up stages, and we got a lot of motors that's working together, some even during the show. So lifting speeds or synchronization is really starting to be more of a hot object. But let's just think about this. As soon as we start a lift, what we actually started with, we energize the stator. Again, the stator is the beginning. Again, it's not all the driving force, but the stator is the beginning of it. All stators are not created equal. And what I mean by that is that if you look over the market, there's stators out there that's really strong, has full torque, has same lifting speeds all the time, but we have to have a secondary way of cooling it down because it's going to get hot. But then on the other side, we have weak stators, but the advantage to those is they will run forever. And a good example of that one is the a ceiling fan in your house. Whenever we turn that switch on to the ceiling fan is slow to come up to speed, but once it gets up to speed, it spins at that speed, and it can do that forever. So as a hoist designer, we look the market over to try to find the one that finds the best line, or that fine line between performance and heat. So the one that works the best in a hoist is not the one that's going to have constant lifting, constant speeds. What I mean by that is the motor that CM uses, we use the 4-pole stators that basically tell us that's 4 poles is going to set the speed in which the magnetics is going to rotate inside of the stator. Our 4-pole stators the magnetics will rotate at 1800 RPM. So theoretically, if there's no restrictions or any kind of resistance on our rotor, then as the magnetics rotate, it's going to rotate the rotor at the same 1800 RPMs. But then we apply a load to it, and because of the extra resistance that we've added to the rotor is going to be behind the magnetics, but it can't be behind past the 1725 RPM as advertised. So what we have right now is we have an 1800 RPM no load speed. We have a 1725 RPM full load speed. Now let's do a little bit of math and look at the those 75 RPMs is 2,204 pounds. That is a metric a metric ton. Our motors are metric rated. So divide the metric ton by 75 RPMs, and you see 29 pounds will slow the revolution of the rotor down 1 time. And within the gear ratio of a 1-ton lodestar, the classics, 1 revolution equals pretty much 1/10 of an inch. Here's the scenario. I've got 2 motors in the perfect world in which we don't live in, where we have 2 exact same motors, exactly the same, and we're supplying both motors with the exact same amount of voltage. The only difference is one's got 29 pounds on the hook more than the other. We run these 2 motors side by side for 10 minutes. The one that's got the extra 29 pounds will be behind the other in 1 inch. So my question is, at this point is, can we actually load to the point that we actually do know that we're within 29 pounds of what we think is that? Some may say yeah, mostly we say no. So again, this myth here is busted as well. Moving on to 3.
Okay, so myth number 3. Is it safe to store a motor in the case with the limit switched, engaged, and opened? Does it damage the motor if I run the chain out to its maximum length and allow the limits to stop the travel before putting it away in the road case? This makes it easier for me to set up at the next venue. So Dave, why don't we go ahead and flip to the next slide so you can share the answer.
Okay. Well, I love this one because this one it will bring rage out into some people that we talk about this, but in reality, yes, it does do damage to the limit switches. And it does it for 2 reasons. First reason is because voltage is what passes through the limit switches, not amps. The amount of amps that's coming through the limit switch is very little. And, voltage is really not that dangerous. To kind of highlight that, have you guys ever rubbed your feet on the carpet and tiptoed up behind your buddy and touched his ears and you make that big pop? Do you know how many volts that you actually sent into your buddy? In some cases, it's around 100,000 volts. So voltage is really not the damaging part, it's the amps. So as our limit switch is activating, the voltage that's going through it really doesn't do any harm to it. What's actually doing is just the fatigue of it. And with that said, let's say that I bought a brand new motor and I put it in the road case and I shipped it from Virginia to California on the other side of the U.S. and the truck driver hit every pothole in the road between here and there, and the ones that he didn't hit, he backed up and got the second time. And as the limits is actually going down the road, if the limit switch itself was just on the verge of clicking, we could prematurely wear the switch out but never really turning it on. So that's one reason that we don't like it to be stored on the limit switches. The second one is because inside of the micro switch is a simple leaf spring. And any time that you put something in compression and you leave it in that compression state for any length of time, then it's going to want to relax to that compressed position. So at that point, our limits is no longer accurate. So again, myth number 3 is actually perfect. Moving on to number 2.
All right, myth number 2. You must regularly lubricate the load chain. Is this really necessary to oil the chain, or is it just a recommendation? I hang my motors in ballrooms and the oil can be messy. All right, Dave, let's see what the answer is on this one.
Okay, this one is very, very close to being the number 1, and in most cases it is number 1. I teach in my classes, absolutely, the load chain has to be lubricated. Whenever we're lubricating the chain, we're not really lubricating to keep the rust off the motor. Of course, that is a plus. We don't want rust to get on the chain, but that's not really the main reason that we put oil on the chain. The real reason is to reduce the friction that's in between the chain links. If you look at this slide here, the way that I teach this is in the perfect world in which we do not live in, where 2 links of chain comes together, we'd have a lot of contact area between those 2 links sharing the load. As you can see here, and this is a finite element study done by our engineers in Damascus, where 2 links of chain goes together, if I put a 1-ton load on it, which is 2204 pounds, where the 2 links actually touch, we have a 6,000 contact area. This chain here is set up for a 5/16 measurement, and so as you can see, at that 6,000 inch, we got over 500,000 pounds of force per square inch that's in between the links of chain. That is a tremendous amount. So without that oil, or oil as I should translate it to be, without that oil, then we got bare metal to bare metal, and we're going to wear our chain out really fast. It is important to lubricate the chain, but it's more important to lubricate it with the right type of oil. Just any kind of oil is not going to work. It has to have the oil that has the special EP additives, which stands for extreme pressure, to make sure that it stays in there, because 500,000 pounds of force will basically squish the oil out of the way. So it has to be the right oil, and it has to be lubricated in an unloaded state, because we've got to get that oil up in between those links. 500,000 pounds of force is not going to let the oil get up in there. So I've heard all the stories, but it is an absolute definite that you've got to lubricate the chain. Moving on to number 1.
Okay, so now we're on number 1. So the number 1 myth, being CM certified means you're a qualified person. I know I hear this all the time. Does being CM certified mean I'm a qualified person and can work on motors? Go ahead, Dave. It's all yours.
The simple explanation of that is no. CM, what we certify when we come out of enduro schools, we're not certifying your abilities. I teach a class. If you guys has ever sat through my class, you know that it is not easy. We have 30% of the people who actually take it fails it. So it's something to really be proud of. But you know, and out of the thousands of people that took it, I've only had 3 that makes 100. So with that said, let's say that one of those guys that made 100 scored 100 on it, but then I saw him struggling to figure out which end of the screwdriver to use. What good is that certification? The certification that we give you certifies your knowledge. We don't certify your abilities. That to determine whether you're a qualified person really lies in the hands of the person or the company who assumes the liability for your actions. CM, like I say, CM is, we just certify that we taught you what you need to know, but we don't say that you're good enough to do what we've taught you. I know that's not what a lot of people think, but it is a kind of a big topic with us. But simply said that if you pass any kind of CM certification, you're not a warranty center and you're not a qualified person. That lies in the hands of the people who owns the liability of it. With that said, before I turn it back over to Gisela, we do a lot of schools. If you allow me to kind of put a plug in for us, this is actually Dave and David. Dave is the one with the hat. David is the one without a hat on this slide here. But we have a lot of fun in our classes, and I travel a lot with our motor schools, and I'd love to see you guys, in one of our classes. Go to our website and check us out and see where we're going to be. With that said, I'm going to turn it back over to Gisela, okay?
Okay, excellent, and thank you all. First of all, on the question of the pickle, I'm going to, after this meeting, I'm going to get with Dave, and I'm going to have him see the comments that were put in the order, and he's going to pick the winner, and then we will notify you, get your address, and send you off one of our shirts. So just to let you know what that is. Okay, now I'm going to go to the questions, and you all typed in tons of questions. So we have about 5 more minutes, and I'll go ahead and ask, and we'll cover what we can, and whatever we don't get to, we will have Dave personally send you an email with those questions. So first of all, let's see. There was a question. Let's see the pickle. Hold on one sec. Miss 10. Miss 10, there was a question. Let's see. What about D8 plus rated hoist? Can you just scroll back to D10 or look on your page, Dave, that you have on Miss number 10? What about D8 plus rated hoist? And let me unmute you there. Okay.
Here we go. Okay, D8 Plus is basically for the entertainment market as far as load ins and load outs, but still yet, a D8 is the hoist that we sell every day. According to the European standards, it calls for the D8 and D8 Plus and all that stuff. A standard hoist as is with one brake, 5-to-1 design factor like we sell every day, you have to have a secondary strap before people can actually get in underneath it and work. The D8 Plus, because it's got a 10-to-1 design factor, and it has a 10-to-1 design factor and 2 brakes. After the load goes up, you don't have to tie it off, and people can get under it at that point. But still, yet a motor, whether it's in industrial or whether it's entertainment, if it's got a full load, it still has the same stresses that's in between the two. Most of the time, the D8 Plus is for entertainment, and it's a traveling show. And you're taking the motors up and down a lot, and you don't want to take the time to tie it off. But still, yet, it's not really intended to hold the load indefinitely. Did that answer the question?
Okay, yes. Another one on Miss 10. Primary suspension not from hoist is often not possible due to setup time limitations for shows. Does CM recommend secondary suspension off hoist for temporary setup always?
Anytime that there's a person that's going to be underneath it, yes, we do recommend that there's a secondary strap. And it's kind of like that. We all know that the speed limit on the interstate here in Virginia is 70 miles an hour. We know we're not supposed to go above 70, but we kind of do. But, the law is, or the recommendation is, we do 70. So with that said, with that kind of in mind, yeah, we still like, if there's going to be anybody under the load, in order to make it safe, we do recommend that you use the secondary, support.
Okay. All right. If you could move down to Miss 7. We have a couple of questions on Miss 7. Let's see. Is there an expiration date on a motor then, or an age range or standard length of use? That was one of the questions. There are a couple more in a minute I'll give you, but that's the first one. So again, is there an expiration date on a motor?
No. Well, yes and no. Now, if you are in Europe, the European does this 10-year FEM rating where they think after 10 years that the motor has basically given its life. we here in the U.S., because we are bigger and we are heavier, honestly, we want our motors to last a lifetime, and they do. You know, we built the very first Lodestar, and we shipped it on February the 10th of 1955. I got a serial number from a customer not too long ago that he bought his, according to the serial number, he bought his in May of 1955, and he still uses it. A lot of the design factor comes on how much you use the motor. If I buy a motor today and I put it up in the shelf and never use it, 20 years from now I'll probably have pretty much the same design factor. Now, if I take that motor out and put it in an application where I abuse it and I really work it hard, but there is no real life expectancy of the motor. And this is not an official, but I would say the life expectancy of a CM motor, we expect it to last a lifetime. It's up to you guys whether you do it right, how to use it.
Okay, a couple more questions on myth number 7, and then unfortunately we're going to have to end for today. But as I said, those other questions you typed in, we will have Dave respond to you personally with an answer. So a couple more questions that just had to do with the safety requirements. So what is the CM factor? Let's see. What if the CM factor of safety for hoist is greater than the 5-to-1 requirement is one question. And then the other one is if the safety factor reduces over time but starts higher than 5-to-1, how do you ensure it never deteriorates below 5-to-1? If you can just kind of address those two, Dave, that would be great, and then we'll wrap up the session for today.
I really don't understand the first part. The second part is you got to do your inspections. You know, your products are going to show wear, they're going to show damages. You know, you got to do your inspections, like we say. That's to ensure. And I teach in my class that if I don't know, as I am doing my inspections, I got to have that in the back of my mind that if I'm working on the smaller guys, not a CM brand, but you know, I'm not going to competitors or anything like that. But if I'm working on the horse that's out there that's cheaper than us and smaller than us, I've got to know that in the back of my mind that they didn't start out with the design factor like we had. So if I'm doing an inspection on those and that motor is showing some wear, I've got to be aware that maybe now it doesn't have that 5-to-1 design factor. But again, the design factor is the factor that's built into it the day it's born. And it's if you was to look at a bell curve, see that in a new state, if you target a 5-to-1 design factor, half of what you build brand new is going to be below the 5-to-1, and half of them is going to be above the 5-to-1. Check that out on the internet, and you'll see that not every product out there is always going to have a 5-to-1 design factor.
Okay, excellent. Dave, if you could go ahead and go all the way to the very, very last slide. I know we're just kind of getting over to the edge of time that we promised we'd be done in 45 minutes. But we just want to thank you all for coming. And if you have any comments or last questions you'd like to ask, please type them in the Q&A pane. Tell us how we did. We're going to send you an email and just shoot us back and let us know what you thought of today. We always like feedback. And again here, if you want to connect with us online, we're very social. We have a blog which has all different types of technical articles written by Dave and a lot of the trainers and other associates at CM. We also have 2 Twitter handles. We have one for CM Entertainment, which a lot of you might fall under, as well as our general industry Twitter handle, which is CMCO Live. We're on Facebook. We post a lot of pictures and updates from trade shows and product updates and other pictures that you share with us. We like to share there as well. We have over 70 YouTube videos on our YouTube channel, how-to videos, all of our history of safety webinars we have on there. And after this session today, this safety webinar will also be posted on our YouTube channel. LinkedIn, we're on there as well, and Google+. So please connect with us. We love to engage with you and learn what you're doing and you know, help make this place, help make all of what you do a little safer. So thank you all for coming today. And Dave, if you have any final comments, I'll make you also available to say something. But we appreciate your time, everyone. Thank you very much.
Yeah, thank you. I really had a lot of fun doing this, even though I messed up on the slides. I apologize for that, but I had a ball doing this. Feel free to contact me for any kind of support or anything like that. And, you'll find me on their webpage. And thanks a lot.
Okay. Thank you, everyone. We appreciate it.